Andy's on European time.
Okay, so let us start. So welcome to this last but not least session. This is the final wrap-up and conclusion session, which I have the pleasure to co-chair with Andrew. Hello, Andrew.
Hello.
Hello. The objective of this session here is to give an opportunity to the chairs, which have chaired their session, and report about the main findings, I'll say the important points they want to convey. What will happen at the end, we will collect all these slides together, and these will be, I will say, the public documents that we will put on websites. So I think if there are no questions, I think we can start with the first session. You have about 5 minutes each. So the objective is to finish around 1 hour, and then we have a surprise. So don't go away until the end. This is very, very important. It's not a trip to Taormina, so don't have a lot of expectations, but it's something which hopefully you will like. So let's start with the first session, which was about sea ice thickness. And Sarah or Henriette, either you show your slides, or I'll ask Matteo to do it on your behalf.
Yes, I can share the screen, but for now I don't have the authorization.
Matteo will do that, and Veronica. Ready?
Yes, there it is. So let's share. Is it okay?
It's great. Just put on full screen.
Yes.
I mean, launch the presentation. That's what I meant.
Yes.
It's coming, at least on my screen. Okay.
Okay, is it okay for you?
Yes, fantastic. Go ahead.
So with my, there were two CI sessions, and with my colleagues, we have decided not to summarize each presentation, but more to emphasize the most important points. So we have one slide for each session. I'm going to present the first one, and Robert will present the second one. Also, if it's possible, perhaps at the end of the summarize, I would like to add some few words regarding the risk of effects of the polar gaps over sea ice. So one slide, it doesn't want to move to the next slide. Okay. No, the second one. Okay. So the first session was related to the sea ice thickness. And one first important observation that we made that the 11 years of CryoSat have allowed to provide very major advances in the observation of the sea ice thickness. And CryoSat provides a unique means to evaluate the ice thickness at the basin scales. And for instance, it is now at the heart of the sea ice CCI project to provide the sea ice thickness essential climate variable. And the CryoSat 2 sea ice thickness data are also used for the annual state of the climate updates on the Arctic climate change. So now it's really get a reference. And more generally, that now I think that we can say that CryoSat is now, in fact, the reference mission for the sea ice long-term time series. Very similarly, that JASONs are the reference mission for the SLA. I think we really can say the same for CryoSat for the sea ice thickness. Also, the measurements over the sea ice have allowed to raise new fundamental altimetric questions, such as the effects of the footprints, the surface roughness, the snow penetration, and so on. And these measurements with the CryoSat from CryoSat has really favored the emergence of new major altimetric techniques to improve the precision and the uncertainties. And for instance, we can see the large progresses regarding the retrackers based on physical model that now are going far beyond the Brown model. which is really important where we are not over the ocean. And we can also mention the full focus SAR that was also largely evaluated over sea ice. Also, we have seen a new synergy to improve the coverage on the forecast of the sea ice. First, thanks to the multi-mission synergy with the SMOS, but also with the Sentinel-3, for instance. And also, this is new, and I think it is really important, it's the new synergies with the models that very allow to improve the forecasts and the predictions. Also, that is just based on this observation, without speaking about models, this observation has permitted some innovative scientific analysis. For instance, the better understanding of the sea ice dynamics and thermodynamics, sea ice circulations, volume, and budget. And to conclude, what it was very noticeable that all the presenters mentioned the need of crystal to ensure the continuity of the sea ice thickness time series. So I think it's an important message also from this session. So now I give the hand to Robert for the second session with the second slide.
Yes, thanks, Sarah. And yeah, I think I will just go on here with the second part of the sea ice session about retracking techniques and snow on sea ice. And I think what we've seen, for example, in Nathan Kurtz and Jack Landy's presentations is the development of new techniques and to improve and advance the processing of altimetric signals. So here, I think we need to mention the fully focused SAR, like advanced retracking algorithms, machine learning, which can be now used to improve the classification of waveforms, for example. But also data merging, because we have so many sensors now in space, and they kind of complement each other regarding the information we get from them. And all these things have been exploited more extensively. I think this we have seen in the presentations, in the oral presentation, but also in the poster presentations. So another point is the focus on this dual band altimetry. So the combination, for example, of Saral Altica and CryoSat-2 to retrieve snow depth that has been investigated. But also regarding surface roughness and footprint size sampling. I think this is an important point to note here. And then we've also seen, for example, in Henrietta's and also Rosie's talk, focus on new airborne and also in situ measurements. For example, here, I'd like to mention this KU, KA, the KUKA, which has been used during the Mosaic campaign over one season, and that was a unique opportunity to observe the snowpack with a dual band radar over the entire winter season. And this will provide us with important information, which is important for the continued planning of the Crystal satellite mission, for example, which is meant to simultaneously derive snow depth and sea ice freeboard. Then we've seen with ESA-2 now, we have an kind of unrevealed data set in terms of resolution and precision. And this can be used and is already used to assess, for example, surface roughness retrieved from CryoSat, and can be also used then as reference for snow freeboard derived from Ka band measurements. And then at the same time, there is this Cryo2 ice campaign to synchronize CryoSat-2 and ESA-2, and this will also give us opportunity to compare both techniques and to potentially derive snow depth. But at the same time, I think that came also out of many discussions and also from the presentations is that in the Antarctic, it's still very difficult because we know very little about the snow there. So we need more in situ measurements to better understand the complexity of the Antarctic snowpack and how it's affecting the radar altimetry. All right, so that's my summary here. And now I think Zara wants to add a few more words.
Yes, perhaps we can go on with the summaries first, and we will see if there are some times to still discuss about the polar gap. I don't know.
Okay.
I think we can have time to do this when Chris and Mark are going to present their slides, so we might have a few minutes there. We did not foresee questions to the chair sessions, but I think we have still a couple of minutes. I don't know what you, Andy, thinks. If there is any urgent question, probably we can put it here on the chat to the four chairs, which I personally thank for having well summarized the main messages throughout the session. And again, I think the main message is really here is that crystal is really going to be not important, but very, very important. And I think this is something which has already been captured in the discussion we had yesterday, and I'm looking forward to that. Okay. Okay, Paolo says it's essential. Okay, yes, indeed, probably that is the right word to use. Okay, so I think if there's no more questions, Andy, how would you want to do this? I continue for another one and then I give it to you. Tell me, give me some.
You're doing a very good job.
Thank you, Andrew. Thank you. It's, I am very talented in organizing events, and you know that.
Yes, yes.
Okay, let's not make this as a stupid joke. CI thickness, I think. Then we went to, and this was already. Did I miss? So CI thickness was the CI thickness 2, and I think then we had on the Tuesday morning we had ocean and marine gravity, if I'm not mistaken, and that would be Michele and Matilde.
Yes, and then there was a second session from where
Christine
chairs
and
were
Walter.
Christine and Walter. And it was prepared a common slide for the two sessions. And
you go ahead, Michele.
okay, perfect. How do it works? I have to share it, or is done by? Yes, I can share it.
Okay, if you have the privilege to do that, why not?
Yes. I think that you can see it. So this is the summary. So there was one keynote, 9 oral, 14 posters. The key points that have been that can be summarized starting from the discussion and the outcomes of the different talk is that the CryoSat data are used in different applications from hydrology, oceanography, and weather forecasting for both research and operation, including near real time. So we have all the spectrum of both application and the kinds of timeliness. These have been has provided the opportunity to have unique insights in polar oceanography, and also a different view with respect to other missions of the global ocean. In addition to this, there was the possibility with the CryoSat to exploit new capabilities, of the instrument, in particular scenarios such as the coastal and the inland waters, with particular attention to new techniques like the fully focused SR. And if it is possible to take this, the statement from Walter talk is that that CryoSat changed altimetry forever, in particular with the advanced capability of SAR mode over open ocean and for coast application. And in fact, we can see now that SAR mode is the de facto standard for any of the new operational mission. We have in Sentinel-3 SAR mode inclusive burst. With Sentinel-6 we have the open burst, and we have also that Crystal will be a mix of these two chronograms, in the sense that it will have both of them, but it will be again obviously a SAR mode altimetry. And also this is the link with the last point, where we will, which is the link for Crystal, where in addition to the capabilities of CryoSat for interferometry, there will be also the Ka band and the extended program. And all these was possible because of the approach that the ESA CryoSat team has had in during the operational life of the mission, where the new user were welcomed and accommodated their needs. And there is the statement regarding the camel in the tent. Each time a new camel points its nose into the tent, we build a bigger tent.
Michele, thank you very much on this, and also on behalf, I think, of Walter, Christine, and Matilde. So thank you very much for this. Just a second. Sorry for this. So thank you very much for this, and I think for having well, I'll say, summarizes the points. We still have a few minutes. If someone wants to add something else, I think they can be captured in the chat, and then. Okay, I'll give a minute. Okay, thanks again, and we can move to the next two chairs. And this is about Greenland and Antarctica ice sheets.
Yeah.
And this was Fight and Ines.
Yes. Matteo, can you share our slides? Great. Great, thank you. So Veit and I are going to present our highlights and recommendations based on the talks from the first session on the Greenland and Antarctic ice sheets. And we also would like to thank the speakers in our session, so Lawrence Gray, Sebastian Simonsen, Tom Slater, and Louise Sorensen, who kindly provided us with their recommendations, and we'll try to summarize all of the different points that were raised in our discussions. Can you go to the next slide, please? So the first point, and it has been raised in almost every session this week, but it's always worth insisting on it because it's a very important point, and it is that we need to keep CryoSat 2 working for as long as possible, and we need to aim for an overlap with Crystal if possible. And that is because long-term time series of elevation change are key to monitor how the ice sheets are changing in terms of mass change, but also in terms of seasonal melting and snowfall variability. And all presenters in our session have nicely shown that in their different talks. And overlapping missions is key to intercalibrate time series of elevation change in order to preserve the long-term radar altimetry record that we have, and that now spans 30 years. And CryoSat, as we have seen this week, has really helped us better understand what is happening in the polar regions, and it provides us with observations at high latitudes, which will be crucial for instance to look at surface mass balance in East Antarctica. And finally, we have seen that radar altimetry and CryoSat 2 data provides reliable mass balance estimates. For instance, Sebastian showed in his talk that using a machine learning approach to calibrate the radar altimetry record gives a reliable mass balance estimate of the Greenland ice sheet. And I also showed that there are differences between gravimetry and mass budgets, but that CryoSat 2 can estimate mass balance, which is essential to help constrain projections of future sea level rise from the ice sheets. And next, we have seen some very nice results in our session on meteorological and fund processes and their impact on Greenland mass balance. And almost all presenters touched on that topic during their talks. And for instance, Tom Slater showed that we can estimate runoff from seasonal variability in elevation change. And Lawrence Gray also touched on this in his talk on the peripheries of the Greenland ice sheet. And what we need to do is to better understand fund-induced elevation change as well as fluctuation in KU band presentation depths in order to get some reliable elevation, volume, and mass change. And Louise Sorensen reminded us of this issue in her keynote as well. So measuring fund processes from space is definitely something that we should look at for the future. Can you go to the next slide? And I think Veit is going to take over for these slides.
Yeah, thanks. So, okay, not only in the ice sheet talks, always we had the question and then the talk about the radar KU band penetration. So there are still things to learn. So we still need a better understanding of the penetration, and especially its time variability, yeah, to minimize errors in the time series trends, especially over the West Antarctic plateau, because here the signal of elevation change is very low, but the timely variation of this KU band penetration is much higher, and so we have to keep an eye on this. And so the recommendation is to use this opportunity now with the ISAT-2 and as well with the Sarah Altica, the KA band, to dig into this problem a bit more before crystal comes, maybe to come up with some solutions already, and to better identify the gathering horizons and to better understand this this fluctuation. And we should also look at the different sampling of the different missions, because it's always dependent where the satellites measures its elevation when you derive a trend and integrate over an area, so you can get the different results. And so it's very important also here to have a look on this sampling. And also Sebastian raised this point that we should also again get more information out of the waveforms, which might also additionally gain some meteorological variables which can be assimilated in climate models. And in a couple of talks, we forgot here to mention the ESA-ESRIN as well. So the SWAR capability as well, ESA-ESRIN opens more or less a new research field. So of course, we are able to observe changes in steep, complex terrain, which was not able before. So a couple of things like lake drainage, glacier surge, and observation of small ice caps, or the highly difficult Antarctic Peninsula is now, thanks to CryoSat, able to detect and observe elevation change. And I think the last point is a bit motivated by Noel's talk. Maybe does ESA need a better control on the antenna mispointing pre or launch? Because by accident, I think CryoSat has a slightly mispointing, which led in the end to the opportunity to use this WRF data also over very flat areas, which is by theoretical is not possible. And so maybe here a dedicated session is needed to define what we need for the maybe coming crystal mission. And I think also some discussions in the CryoSat working group were about the rigidity of the antenna frame, and if we can measure this in space to get a very accurate measure for the phase, which is crucial for SWARF, especially SWARF processing, maybe more for than SWARF processing. So please, next slide.
Yeah, so next we have listed a few points that we need to keep in mind in preparation for crystal. So for instance, we need to explore the impact of switching from LRM to SAR in the ice sheet interior, as SAR could be less sensitive to radar penetration depth. So once again, we need to look closely at the scattering horizon of KU band in different modes of operation. And for that purpose, PLRM could also help with this kind of comparisons. And it's very nice that PLRM data would be included in the next CryoSat-2 baseline. And also included in Sentinel-3.
Okay, and the last point we have is we need the right missions in time and space at the same time. So because only with concurrent missions we are able to understand what we see with altimetry. We can learn much more when we have several data sources, as well as, which I want to highlight here, we need always validation campaigns, ground truthing, airborne campaigns, really to understand the signals we see with CryoSat or with the altimeters over the ice sheets. It's really key to understand and to be able to interpret the signals. So we mentioned it a couple of points, but I think in most of the talks it was clear that always a combination of different data sets is crucial. So I think we are ending here, and also would like to thank to the whole CryoSat team who enables us to have now 11 years time series of excellent data with products which are always getting better and better. This is really, really nice to see, and yeah, thanks a lot.
Thank you very much, Veit and Ines, for this very nice, we'll say, summary of your session. I will forward your thanks to the team, of course, which most of them are here today anyhow. I see a few notes on the chat, which I think Paolo raised this question about mispointing. I think was just right, the fact that we were mispointing, that we could solve a problem on the face for the swath. And I think at a certain point in time, we even discussed the fact whether we could roll the satellite in order to have a better, I would say, characterizations of that. One thing I don't want to open discussion here, I'm not that familiar with Crystal, with the latest baseline, is that we're not going to have Ka interferometry. Is that right? We only will have Ku, and the question is, what was at the end, Paolo? Why, or even Jerome? There was a reason for this, or am I wrong?
For having source only in Ku and not Ka.
Yes, is that?
I guess it's because we build on the heritage of CryoSat, on which we know to manage source processing from Ku. For Ka, it's not already done. It will be done with the SWOT, the NASA CNES SWOT mission, which is planned in the coming years, and will be a source satellite mission. But until now, only CryoSat were performing some source data in Ku. Regarding technical limitation from Ka to do so, frankly speaking, I don't know. I don't know if colleagues know if there is limitation or not.
Probably Mark just pointed out it could be the chronogram, so we cannot do everything, basically. Okay, thank you very much for this excellent summary to Ines and to Veit.
Tom?
Yeah?
So Ines raised something, and Veit also touched on the same point about continuity of data and maintaining the lifetime of CryoSat. There is a question for the community, and there are some people on the call, as to whether or not they would encourage us to maximize the lifetime by switching to the redundant power chain now, with the associated risk that might carry, as opposed to maintaining the system in its present configuration and not switching to the redundant, sorry, I didn't mean power, I meant the propulsion system, until a later date. I'm not sure that everybody is fully aware of the fact that the maximum lifetime of the mission is dependent upon when we make the switch.
Not only,
but in one of our failure scenarios, should I say, if the failure scenario is related to the propulsion system, then it will be dependent upon when we make that switch. So nobody's going to take this decision, it's Tom's decision, but it would be useful to get feedback from people at some stage, at any stage actually, as to whether you would like us to attempt to switch sooner rather than later in order to extend the mission longer.
Is that a question to me or to the community? Sorry.
To the community. You and I have discussed this at length, and so it would be great to have the support or otherwise of other people, and so just post your answers in the chat. Do you want to give a headline example of the nominal lifetimes based upon the switch of the propulsion system? Can you remember them, Tom?
Sure. I can remember that. I mean, it's but the thing is, we have to give a bigger picture, and the bigger picture is the following: the lifetime of the satellite will not only depend on the fuel, but will depend on the battery as well. So we are looking carefully and trying to make the right decision at the right time. And based on this, we came up with a baseline that we should change. We should go for the change of the reaction control system to be not later than 2023, May 2023, because if we go later than that, we only will have like 1 year of fuel remaining on the satellite. But on the other side, the problem is that switching to the reaction control system, it's a game which we don't know how it will end, because it is also talking to industry. It can be done. We have the procedures. The satellite has been designed to do this, but now has been like 12 years, 11 years in orbit, and we are not sure that the housing of the valves will go back to the right position, the installation. So it's a really risky business. And doing this, whenever we're going to do this, it has inside some risks, which means that it could even be end of mission. So we have to trade off the two things: whether we're going to risk to have an end of mission earlier than expected, or we have to try to keep on going until a kind of a break point, taking into consideration as well the life limiting items, which the main one is not the instrument, it's not the other switches, is the battery. And industry says that, I cannot show you the graphs today, but industry says that more or less the degradation of the battery, thanks to the work we have been doing so far, will be linear until, I can't remember now, I think 2026, end of 2026. And then anything that we have no enough models to predict what the lifetime of the satellite will be. But they say probably it will still be linear for another 6 months. So putting all this together, if you want, in a picture or in a graph, it makes sense not to risk the mission now and wait until the last moment, more or less the last moment, keep in consideration that also the batteries and everything else, and do the switch in spring 2023. That will give us the chance to have another 2 years of winter Arctic with the CryoSat 2Is, and we know that ISAT-2 probably has enough, I would say, resources to last for another 6 years. And at the same time, we can do we'll be able to do this the campaigns which I showed you yesterday. But when we do the switch, it will give us enough fuel, not battery, to last for another 5, probably 6 years. But that would depend on the solar activity. So 2023, if we do that, and we are lucky enough, and the other systems are behaving correctly, and of course we don't have an hiccup, we probably can reach the end of the mission, more or less the end of 2028. But this is, of course, is a big question mark.
So I think.
Yes, Richard, of course, everyone is really involved in that. Absolutely. Absolutely.
But it's contingent still, Tom, it's still contingent upon, in the meantime, having full confirmation of extension of mission. So there's an additional step in between as well.
Absolutely. This is something, but that I don't have a lot of problems, because, I mean, it came up out of this conference that we need more altimetry missions and not less. So, and this conference is going to be extremely important to argument that. So I have no issue on this, but nevertheless, we have to go through the procedure. It's going to take time for us to put things together. And of course, we're going to show at the time of Aceo, and I think Chris will be part of it. I'm going to give a couple of slides to explain with a lot of clarification what the situation is. And then, of course, I will accept recommendations from them. To answer to Richard, yes, indeed, this is something which everyone really is involved, STEC, PLSO, and industry. It is something which we have been looking since 2016, and I must say about credit to FOSS, who found the reason and understood where this leakage is coming from, which then is on a thruster basically, which is giving a roll to the satellite, and which we are compensating now with the magnetotorque. But at a certain point, we will also have to compensate with the thrusters. And we have done a lot of simulations, emulations, and analysis with industry. And the good answer was actually that even if the leakage increases by a factor of 5, the AOCS control system is still able to counteract and counteract the I would say the torques, so that still the performances in accuracy and measurements is still preserved. But we don't want to go there, because 5 times more than what we have today is like we have left with 6 months of fuel. So we have to do it before. And I think by looking at all the possibilities between January and June 2023 is in our view today, based on what we have, based on the data we have, is the best time to act.
So I think this is a really good example of a difficult decision to have to make, and it's a good situation to be in, because we can prolong the mission lifetime in different ways. What I would say, and I don't have a strong view either way, I just want to make sure that we're not doing something that is at odds with the views of the community. If people want to do something different, switch tomorrow, which it obviously can't happen, but sooner, then we could prolong the life longer if the other items didn't fail. But this nominal date of making a switch in 2023 is really a hard deadline for us to organize some contingency plan for surveying the polar regions before then. If we have nothing off the ground before then, 2023, and we make the switch and it fails, then we're in a really difficult situation. So I think it places some urgency on the other activities that we've been talking about this week to try and bridge the gap. They need to be committed to before we make this switch, I think.
But 2023 is tomorrow. I mean, unfortunately, it is tomorrow for us. By the way, we are working on the background, because, of course, staying in this situation, and this must be said, it's not safe. It's not 100% safe, because the leakage it doesn't have I would say strong acceleration, but it has some acceleration, and it could happen that tomorrow the seal of the thruster breaks, and the fuel goes out, and we go into safe mode. So automatically it will go to the redundant side. So what we have done so far, anyhow, not to prevent this, but to be ready to change to redundant side, is that we have gone through all the procedures. This is everything which is, things on the operations which are going in the background, and we have uploaded new operational procedures on board the satellite and reviewed the ground ones, is that even if we go to RCSB, we still can retain AIM if this is the case. So we are ready to go tomorrow. This was our deadline by the end of June, and internally with FOSS, and we are ready to do that. And but of course, we just have everything ready, and we will not do it. At least this is our idea until spring. I think I see a few things here, probably on Sinead. But serious point, can you clarify based on all the different options to have to consider the best expectation we can have to CryoSat 2 might be? Now, I don't have all the figures, but in my head, but it's I have a graphs, of course, and numbers. But if I correctly remember what the situation is with the current knowledge of what we have on the solar activity and 11 years of using the fuel, because we have been in a kind of low solar activities, so we have used less fuel than expected, and also the ballistic coefficient has been different in our favor, I would say. So if we do in 2023, we will have then two curves. The worst case scenario, I think it's around mid 2028. Please don't take these numbers as deterministic, because there are other things which are playing. And then I would say what we call the nominal or optimistic gives us probably another year. But that kind of curves change every 6 months. So if we say fuel-wise, by doing that change in 23, give us hope to be able to operate the satellite fuel-wise until end of 2028, I think this is a kind of a statement which we can even say publicly. But on top of this, again, we have the battery.
So I think we're probably running out of time, so we should probably move on to make sure we capture everything else.
I hope I try not to confuse you, but
no. I mean, I didn't mean to. Well, I think it's an important issue to air. This is the CryoSat community who are on the call, and so the decisions really, you know, we get longer lifetime the sooner we switch. If the switch works, Richard will tell us we should switch because that's what the switch was designed to do, and you may all share that view. But in any case, write in or write in the chat your opinions and we'll collect them.
Yes, if you write on the chat, I think someone, either Matteo, Veronica, please copy and paste, and I'll be happy to them to either answer the questions or to take in consideration your recommendations. Okay. Who's next? Sorry, I lost contact with reality. Next one is Mal, isn't it? Yes. It's Mal with Angelica.
Can I please get the permission to share the slides? And Mel cannot join in, so I'm going to present it. No, that's screen. Stop. No, that's not the right thing to do. Here we go. And now in presentation mode. So we had a couple of very fantastic presentations that were showing that basically CryoSat 2 continues to enable science. This is everything in short, which is very important. And I'm absolutely delighted to hear that we could dream of end of 27. So most of the things in our session were about what we can do on monitoring the evolution of the ice sheet, how ready are we to survey an instability of the West Antarctic ice sheet, and subglacial lake drainage events and these things. So I mean, if you look at the presentations we had in the past years, I think in this year, you see that what is done with the CryoSat data at the moment has gone a different route in terms of now you have this Bayesian statistical modeling approaches. Now you are getting into, and that's probably on my next slide, getting into using machine learning in the analysis because you recognize that an automatic detection would be more useful or would be feasible or in reach, something what you can now plan, which you would not have done 10 years ago. So I think in that respect, there were a couple of things that were kind of shading a light also into the future already and what we will be able to do there. Then we had a fantastic presentation of Ghislain, and I think what a point that Stefan Hendricks made was very important. This is a model that is open source now, and coming from the ice sheet modeling community myself, I know that this is a game changer. Having this type of modeling available for a wider community will draw more people into, more students into, and this is, from my perspective, a very important point. And I think, so I'm not very much experienced in these areas, but I think there may be also connections to couple this type of model with firn densification models and firn hydrology models in the future, if we kind of get into an exchange and see if we can design the interface as well, if we can deliver that. I think this is also something that we could think of in future. All right, and then one last slide. This was not part of the session, but I wanted to mention this. When we were presenting in Germany, within Germany, CryoSat and in particular the plan for the Crystal mission, to a couple of representatives from the space management. Veit had a very cool idea in how to think of what we would miss if we would not have CryoSat and if we would not have Crystal in orbit. As I've shown you in my presentation, is that it is very likely that we get more accumulation in snow in the interior of the East Antarctic area. And this is an incredible size of area, and Sentinel-3 is missing 20% of that area. And if you only have a change in accumulation by 1 centimeter per year, then this amounts to 28 gigatons of uncertainty per year in mass loss. If you have a coverage of up to 88 degrees, you only miss 1% and only 1.5 gigatons per year. Yeah, and this is, I think this figure is very important in thinking of what we would lose if we would fall back to a coverage like Sentinel-3. All right, and in short, of course, no gaps in altimetry covering polar areas up to 88 degrees.
Thank you, Angelica. I think Andrew can comment on this. I just want to say that we had a hard time, me and Andrew, in different, even speaking to the member states about just saying what you said here. And I would add also the fact that with CryoSat and interferometry, we are capturing loss of, I would say, ice where the dynamic, more the dynamics are happening. They were saying, well, we have Sentinel-3, why do we didn't continue and mission extends and CryoSat-2? And you remember, Andrew, a lot of discussion trying really to put it like in a small picture and drawing, this is the hole we are missing, and here's this. So remember, Andrew, this discussion, I think Andrew is trying to fix this.
Yeah, I mean, no, I'm turning the mic on because the kids just came home from school and you don't want to hear that chat.
No,
the argument we've used in the past, Angelica, is about the sampling pattern that Sentinel-3A and B offer and the proportion of the coastline that's mapped. Even though the coastline is mapped, it's mapped with much coarser spatial sampling than CryoSat as well. So we've got a similar statistic on the proportion of dynamical imbalance that we capture. And so I think your snowfall one is actually, Veit's recommendation is really useful because I haven't thought about that, but now I recognize the disruption that was caused by the GRACE gap. The gap between GRACE and GRACE follow-on is actually hugely disruptive to the mass balance time series in ways that people didn't really anticipate. And for the sake of 18 months in the lifetimes of 2 missions that are expected to be 20 odd years, it's careless. And of course, everybody worked really hard to avoid that gap. But that's what we're trying to do with altimetry, to make sure we don't have it, because you build in a legacy of this error. You can't get rid of that error. It's in your time series forever if you have the gap. So it's a really good point you make. Thank you.
Yeah,
Thank you for
and I
that.
think it has one more impact. If you want to do, if you want to take mass loss products and use that to simulate local sea level change, and this is the only thing that coastal planners are interested in. They don't, a mean sea level change doesn't help them at all. They want to have coastal values. And in that respect, if you are missing that area, then the uncertainty that you have in the local sea level due to self-gravitation in this simulation, that may make this type of product not useful for them at all. This is also something that we should write down and think in terms of communication from my perspective.
Thank you.
Thank you. I think I see, I'm just looking at the chats. Yes, indeed, Richard, this is the situation, and we can give you, I think Richard is just commenting on Andrew on the previous, but I think we can go on. You have time to read this on the chat. Okay, let's move. Thanks again, Angelica. Thank you, Angelica and Mal, for having put this together as a summary slide. And I think we can move on now with Lawrence, Sushila, Anna, and Beth. I don't know who of you are going to show us the slides, but please do it.
Yeah.
Lawrence, okay.
Could you enable the share for me, please? No, I got the wrong one, sorry. Try again. Okay, this will be quick. Our session was devoted to glaciers, ice caps, ice shelves, and icebergs. So pretty much all the glacial ice except for Greenland and Antarctica. And I think there was one theme that came out from most of the talks, and that's related again to the value of the long time series that we now have with CryoSat. We have 11 years and hopefully a few more years. And I think I'd like to emphasize that thinking back to 2013, say, we noticed that the value of the data from 2011 and 12 was great. We were learning how to process the data and it was useful. But think ahead to 2025, that data from the early CryoSat period becomes more valuable. And I don't think it's just a linear increase with time. I think it's more like a quadratic increase in time. And as we get more and more data, then, and I think Helen highlighted this, we have to improve our communication of the change we see in the cryosphere. I think in this regard, the younger remote sensing scientists are doing a much better job than the old guys in the field. But now I'd like to move on to some of the recommendations that came out of the presentations. And as Ines said, I think the key one is let's keep CryoSat working for as long as possible. The second one, I think, really, let me talk about in a little bit more general terms about the second one in terms of implementing open loop tracking in Crystal. I think that when we started CryoSat, we didn't anticipate that swath mode data was going to be as valuable as it turned out to be in particularly the area that we were talking about, glaciers, ice caps, and ice shelves. And I think it's, if we can keep a flexible approach to this, I think in the past, often with satellite programs, the users are asked to come up with the requirements. That gets turned into a document, which becomes a little bit like a little fixed. It's passed to the engineers and a system gets designed. I hope with Crystal it can be perhaps a little bit more flexible, that there's a continuing dialogue between the managers, the engineers, and the users. I know that some of the things with Crystal are now fixed, the bandwidth, for example, but I hope, for example, in the processing, that it would be possible to have not only open loop tracking, but also the possibility to upgrade a reference DEM. Another point is I know the bandwidth is fixed, but is the range window fixed? Again, I'm not sure. Okay, next point. I think all of us in this group and pretty much in the community, we don't use CryoSat in isolation. It's always used in synergy with other airborne and satellite data and various models. And I hope that ESA sort of remembers that. I know that there's this wonderful program linking the orbit of CryoSat with that of ICESat-2, but I think in other areas as well, ESA should be encouraging work which increases the use of CryoSat data in synergy with other data as well. And finally, again, this issue of what happens if there is a gap between the end of the CryoSat mission and the launch of Crystal, and perhaps it's likely that there will be. But then I think of what NASA did with their IceBridge program. I think that was a wonderful program. I think maybe ESA should consider a similar expansion of their airborne program if indeed there is this gap. And that pretty much wraps up our single view graph. I'm not sure if Anna is online, but I would welcome any questions or comments from Anna or the other hosts.
I think you've done a fantastic job there, Lawrence. I don't have anything to add. You've summed it up perfectly.
Thank you very much. So if there are no questions on this session, thank you, Lawrence.
Maybe
thank you, Cecilia.
Just one comment
Please.
regarding the last bullet point, just to make you informed that we have had already some internal iteration at ESA regarding a kind of European operational ice bridge, a cryo bridge, that we start discussion on that. We may have a dedicated session on that topic at the next Living Planet Symposium. So we have proposed this session, allowing to collect additional recommendations from the community in order to set up this cryo bridge. Of course, it will depend on future funding. We may have to future ministerial 2022 or 2025. And of course, we will directly rely on outcome and input from the community to refine the plan for this potential campaign. But at the end, it will depend on money and to be able to manage this kind of European OIB. But it is an ongoing discussion we have.
Okay. Thank you.
Thank you. I suggest to move on, otherwise we're going to be in trouble for the surprise I was mentioning. So let's go to the next session. And Jérôme, either you or Tanya, you want to present this?
Yes, I can share my screen if I can. Share. Okay. Share content. Okay, you can see my screen?
I'll answer because Tom's gone out to watch what's happening in the sky, I think. Yes, we can see your screen.
Okay, perfect. So I will try to be quick. So it was a pleasure for me to co-share this session about 10 years of operation synergy with Earth observation mission with Tanya Casal. I would like to thank all speakers for this 5 exciting talks covering a wide spectrum of topics and showcasing key components and challenges to be tackled for an operating mission such as CryoSat. So first, we had a presentation from Tommaso focusing on 10 years in space, status and future challenge of CryoSat. Tommaso highlight all the nice science results which has been achieved by the mission over the last 11 years. It has been confirmed that the mission is extended until 2022, and we are currently preparing an extension to secure funding until 25. To do so, we need to maintain the CryoSat mission in a good shape, and the status of the mission is still in excellent shape, from data acquisition until Calval activity and generation of high quality CryoSat product, which are used by a growing and versatile user community. Tempo and Eolis data concept, new concept, and synergy with ISAT2 through the CO2 ICE activity are an ongoing success, opening the door for many new applications from CryoSat in synergy with other mission. I take the example of snow retrieval from CAIU and laser observation, which is a hot topic to be addressed in the coming years. To do so, we need also to have the support from our colleague from FOSS. In this respect, Giuseppe give an overview of operational tasks and main achievements from FOSS in support to CryoSat for more than a decade. More than 4,000 days in orbit for CryoSat. The team has been challenged with several anomalies over 11 years while finding agile solution to address spacecraft aging. This has been even more challenging over the last year. In COVID time, indeed, the FOSS was not, I would say, designed in order to manage some operation from home. So it has been necessary to accommodate from some change in order to harmonize remote working, which was a big challenge. CryoSat has also demonstrated to be a valuable source of observation from many other applications beyond its original scope over the cryosphere, including hydrosphere, atmosphere, geosphere, and even geospace. And in this respect, also FOSS colleagues have been very, very instrumental in supporting the development of magnet data from CryoSat mission, as shown by Niels in his presentation. A reminder that such a success story cannot be achieved without a strong dedication and hard work from our CryoSat expert support laboratory in order to perform calibration and ensure the top quality and long-term stability of our level 1 and level 2 core data product, which are both fundamental to address climate change issue, which are core mission objective. This has been shown during the presentation both by Michaele and Steven, demonstrating level 1 data quality and excellent data quality, level 2 as well, with more than 300 million measurements from SIRA level 2 data product obtained over the last year. So we'll now let the floor to Tanya to continue to present other talk.
Thank you, Jérôme. So for me, I will talk about the fourth presentation, which was about crystal, and it was given by Paulo. And in fact, Paulo did show that the CryoSat's technology and the scientific importance really paved the way for crystal. And without it, we wouldn't be where we are today with crystal. Crystal will be the first high-resolution operational radar altimeter for the cryosphere, with a launch expected for 2027. So it's a Copernicus expansion mission. And the latest status is that right now the full consortium, which has already quite an extensive altimetry expertise with the CryoSat and also Sentinel-6, has been established for the space segment development. We finished this very interesting session with a talk from Thomas Newman by giving us his latest updates and status on the ISAT-2 mission. So he introduced, for those of you who don't know, which I doubt if there's anybody here, that their Atlas system, so their advanced topographic laser system, and the mission objectives, which are to measure ice sheet elevation change, the ice freeboard, and enable global vegetation canopy height assessments. He's also showed the unprecedented high-resolution measurements and the very interesting new discoveries, which they were not expecting, as the ability to, for instance, sample the Arctic summer melt ponds, or even the clear shallow waters in the Caribbean. And he also highlighted the international cooperation with ESA, the importance of it in the form of Cryo2Ice, the latest one, because we've had other collaborations in the past. But in particular, the ongoing Cryo2Ice collaboration has been offering a unique opportunity for this coincident laser altimetry data over the polar areas, which, as you know, are key for our understanding of the global climate system. So this is all from us on this first session on synergies with the EO.
Thank you, Tanya. Thank you, Jérôme. I don't see any questions here. I think there's some discussion going on the chat about also the previous question. Thank you. Just one thing from Steve. Yes, we need to correct the measurement from 300 million to 7 billion. So I think we can do that. And just to let you know that I think on the first week of August or second week of August, I can't remember now, I think it's the 12th of August, CryoSat will have done 60,000 orbits around our beautiful planet. So there's another thing to recall and remember there. Okay, I will then move to the next session. As you can see, we're getting all the fingerprints of Andrew. We know everything about your fingerprints now, and you can see. So let's go to the next one, which is the Future of Altimetry. Chris and Mark, we are looking forward to this.
Thank you. Could you let me share my desktop, please? Thank you. Let's see where we are. Okay. And can you see my screen? Can you see that?
It's perfect.
Good, excellent. Okie doke. Well, firstly, just let me say from my personal point of view, after a 25-year gap from altimetry, I've been absolutely blown away by the quality of the work, the quality, the way things have advanced, the extraordinary science, and indeed the quality of the presentations. And I think there should, at some point, be a round of applause because the quality of the presentations has been really, really good. So Mark and I put together this session on the future of altimetry, but in fact, as we've seen both in the presentations and in the summaries, a lot of people had included some thoughts and recommendations about the future, so we didn't cover them comprehensively. We just focused on the 4 wonderful presentations that we had from Valérie Masson-Delmotte, looking at where this sits in the kind of world of IPCC, Angelica, and the vulnerability of Antarctic ice, Laurent with this long journey that we've been on from the relatively primitive altimeters in ERS to where we are now and where we're heading, and then Andy's kind of thoughtful view of where we're heading. So we've got 3 slides. One is scientific challenges, and so we picked out the following: snow depth on marine and land ice, the need to better understand solid precipitation, freshwater balance at high latitudes, clearly an issue, the variability in trends in Antarctic sea ice thickness. This is quite troublesome that here we are still struggling with that as an issue, something that we identified, literally 40 years ago as a key climate variable that we needed to get a grip on. Ice sheet instability and the onset of other irreversible changes. So these, Andy made the point that if you look at the world map of tipping points, an awful lot of them, not surprisingly, sit in the area where ice can turn to water, and then using Earth observation with in situ models to try and get a grip on those. Not least because the whole point of COP21 and the 2 degree or 1.5 degree limits was to try and prevent us from going from potentially controllable climate landing in the future to one where the planet takes over and lands us in potentially much more uncomfortable circumstances. And then the beginnings of recognition that the information products derived from high latitude fundamental data records are becoming increasingly important for decision making throughout society, and risk assessments are one mechanism by which those decisions can be made. So very quickly, the recommendations: continue the development of dual frequency measurement capability on marine and land ice. This is repeating a kind of drumbeat that's been coming out of the presentation so far, to better understand snow depth, impact on thickness retrievals, understand freshwater balance, help with the Antarctic sea ice, and so on. Improve the capability to measure variability and trends in Antarctic sea ice thickness. Develop information products for climate risk assessments based on fundamental polar time series such as ice sheet mass loss. And then improve the dialogue and co-production between climate, ocean, ice modelers. So I remember very early in my career sitting in a meeting where modelers and measurement scientists were brought together, and they were like 2 separate tribes. So it's interesting to see that there's still occasional tensions in that area. But more importantly, to bring everybody into the room, the Copernicus service providers, the Space Agency, and an increasing selection of policymakers, so that we can all work together to rebalance what I've called discovery mode science, discovering new things about the way the Earth system functions, particularly the polar regions, but the delivery of value and benefit to society, which is something that we're less trained for, less comfortable with, it's more complicated. But by goodness, if we want the operational systems to deliver the science that we need, we need to get better at that. Technical challenges: dual frequency, high bandwidth, multi-antenna, fully focused, multi-purpose, SAR, interferometric swath altimetry. I mean, you name it, it's extraordinary, the kind of glittering array of technical capability that has been built up and is being pursued. Keep at it. Intelligent open loop tracking, we just heard references to that, with the ability to refresh the elevation models in dynamic regions. There was one reference yesterday to polarization diversity. It's an interesting thought and could be pursued. Certainly in other fields, polarization provides useful additional information. Radar altimeters optimized for use on small stat constellations to improve time-space sampling, despite Richard's very relevant point that you still need to wait for your launcher if you're hoping to get a cheap ride with a whole bunch of small sats. Then combining instruments, combined altimeter, imager, radar, laser. But as we've seen with the recent EE-11, Earth Explorer 11 submissions, the costs of complex active instruments often pushes these concepts beyond what is currently affordable. So there's a programmatic issue that has to be addressed along with the technical and scientific one there. Optimization of altimeter orbits and Copernicus observing system architecture to maximize multi-mission co-located sampling. We heard a little bit about that just now. So recommendation 5, continue progressive evolution in altimeter capabilities, ensuring enhanced continuity. Pursue the possibility of high latitude snow ice altimetric capabilities using small sats. Interesting idea. Others are already pursuing this. Recommendation 7, community to actively propose innovative new cryosphere mission ideas, Explorer and others. It was interesting in the EE-11 15 proposals that there was a predominant focus on atmospheric missions. There were some cryospheric missions, but it's, you know, the community really needs to reflect on, you know, if you don't ask, you don't get. So, so that recommendation is an important one to think about. So finally, the challenge of the transition from research to operations. The research and user community efforts are needed to transform the perception of the importance and priority for operations and for climate action of polar altimetry in the Copernicus expansion. And we've just heard, you know, underscoring the need for crystal, the argument that Angelica put forward about that, you know, you lose that coverage of that close area to the pole, and you're missing some crucially important information, not just for science, but for decision makers. Aim to secure a stable, well-calibrated operational time series, well, with complementary observations such as SAR and optical imaging capabilities. Operational polar altimetry needs to assure the overlap and continuity of critical polar climate data records. Well, this has been repeated time and time again. So what recommendations? Well, recommendation, you know, I sit on the advisory committee for Earth observation at CHEO and chair the European Space Sciences Committee, as you know. ESSC has good contacts with ESA, the EU, and indeed many others. So what we're considering is for ESA, ESSC, and EU to investigate establishing a user forum where we can bring altimetry experts, ice and climate modelers, and societal decision makers together to establish and promote high-profile climate cryosphere altimetry future priorities. So this is something that we'll take away and more than nibble away at. We'll see what we can do. And then I'm interested, it didn't really come up so much in the session, but I've heard it mentioned, you know, in the other sessions and in the recommendations just now. Pursue systematic airborne capability for CalVal and airborne mapping of polar regions in conjunction with the EC. Now, the SSC has already had one bite at this. Our polar Earth observation panel, not polar panel, Earth observation panel, produced a paper which we submitted to ESA and the EU a year or so ago about recommending that there should be a European CalVal service for Earth observation, because we felt that this was not fully understood in the Copernicus world, for example. And there's a reference paper there that people can look at. So again, you know, keeping the and we had some feedback that this had been acknowledged and there was some reaction to it, but we need to keep the pressure up on this. So that's my contribution. Mark, did I miss anything? Do you want to add anything?
No, not particularly. I think you touched on all the highlights. There's one complementary piece of information, of course, that hasn't been brought up in this meeting, but which was also the central focus of our EO for Polar meeting late last year, and that's the fact that we are systematically trying to co-align our respective program elements in our future EO program with what the EC is doing through Horizon Europe. And it's with good intent that we want them to inject items into their work plan in the future that can help us to complement what we're able to accomplish in our own program through ESA financed activities. And so it is our intent to continue to pursue that collaboration. Whether we can inject calibration validation in there is a good question. But certainly from the standpoint of the science, we have developing relations there to try to make sure that what's going on through future multi-annual financial frameworks of the European Commission, that there is a strategic underlying focus on the polar regions, and you'll see that developing through the EU polar cluster. You'll see it through the various efforts to join together the thinking amongst a wide variety of EU-funded projects, and we're trying to align what we're doing from a research and development perspective with those activities, and we have an ongoing dialogue to try and make that a fruitful co-alignment of our respective programs in the future. So that's something to look at. But I would add to try to tap into that effort insofar as possible, to make sure that those projects which are being instigated through and under EU funding are aware of the types of concerns that have been raised in this meeting. And there are a variety of new projects coming out through new Horizon Europe funding, like Arctic Passion and a number of other projects into which, of course, you can inject the thoughts and the priorities that are coming out of workshops like this. So I can only encourage you to use whatever means you can to tap into these activities and to make sure that the priorities of this community are somehow recognised in those EU projects. Thanks, Chris.
And thanks for looking at the chat box. Thanks for those comments. We'll take those into account. My final comment would be that the synthesis of these syntheses, I think, is going to be a very powerful document if we write it correctly. I don't know how the organizer is going to do that, but obviously Mark and I'd be happy to help. But the other thing I would just say is that you know, we've had lots of camels and elephants. It's the squeaky wheel that gets oiled. And if we're not out there, you know, promoting our, or I say your, it's not mine anymore, but your interest in this particular crucial piece of science, and the use of space to achieve it, at every possible opportunity, you know, every time you're in that elevator with your local MP or whoever it is, you know, then others will get ahead, because you know, I have to say, looking at the EE11 15 proposals, there were some terrific proposals from other fields, and you know, so it's a highly competitive world. So the onus is on everybody to be out there fighting for the future.
Chris, Mark, thank you for these slides. I think you've done tremendous work there to put together these seven or more recommendations. I think we are really looking forward to see the outcome of that in this document, which Chris was saying the other day. And we are looking forward also to have your support for the mission extension. Okay, I think we need to move ahead, and I would like to give now the last two sessions, and I think we have yes, it's going to be Monica and Nathan, and they will tell us about 10 years of operational synergies with Earth observation missions. So please go ahead.
Thanks, here. I'll share my screen here.
So it's daylight now, Nathan. Yes, indeed. Got it. We got there eventually.
I was gonna make the comment that, yeah, it was 3 a.m. So this is not a pretty slide that was put together here. Yeah, Monica, why don't you start with the first speaker here? Let's see if I can get this screen.
I've got a very bad connection, so sorry if it goes in and out, but we'll try with a couple of speakers and then we'll share between Nathan and myself. We had a quite diverse, let's say, session. So and the different talks are rather independent from each other. We started with Isabel Lawrence, and she showed CEA-ESRIN board from CryoSat and Sentinel-3. And that Sentinel-3A had about 1 centimeter bias, 1 centimeter that had to be subtracted from Sentinel-3 to be as CryoSat-2. And by combining the two data sets allows for a denser spatial sampling, of course. Additional variability found in 9 days versus 30 days records, correlation with the snow depth changes in 9 days records, poorer correlation between the multi-year ice at the different winter time periods. ISAT-2 also show some correlation as well. With snowfall, one would expect to show the rate of freeboard to be smaller due to two different reasons: the snow weight on one side and the radar signal that is delayed through the snow, and therefore making a larger delay. And the results show the contrary. Ice drift potentially impact the reasons for the lower correlations. Nathan?
Okay, and then the next speaker was Paolo Cipollini. Paolo talked about presentations from a conference on multi-band altimeters, so talking about the KU, KA band altimeters, also cryo to ice, so laser altimetry as another band, so to speak, here. And again, really summarize that this provides for a much richer data set if we're providing multi-band results. So yeah, he summarized the results of this workshop. I think Isabel raised this in the comments just now about polarization. Need for a specific mission or experiment analyzing changes due to looking at different polarizations. There was also a question or a comment about, do we need a snow radar for validation of altimetric differences, which has been flown by NASA and AVI. So I'll stop there. So Monica, for the next speaker.
Yep. It was Laurent Ray, and he gave the highlights of the early design of serial and 10 years of flight monitoring. So we had a nice history back to the early times. Improved track, he showed that, well, improved onboard tracker compared to the ocean missions was important because it clearly had more challenges, and it showed 1.17% of acquisitions, meaning missing data, due to this improvement of the onboard tracker. About 1.9 dBs loss in power since October 2010. Mostly we understood during the first 3 years, but only a small trend now of smaller than 0.01 dB a month now these days. Still operating on the nominal chain and could continue doing so for another 4 years. And well, we had a discussion on that.
Okay. Next speaker was Mark Nae. He talked about using CryoSat 2 for ocean heights. Some of the things he was looking at was using identical models and seeing, okay, what are some of the differences that we're seeing with them, especially for ocean tracking. Mark highlighted there's a number or quite a few numbers in here. I think one of the points that he raised is that the GIM ionosphere corrections seem to be one of the bigger differences that they were seeing, in excess of 1 centimeter difference. But overall, that the corrections didn't seem to have any kind of large impact on sea level trends that we're seeing from CryoSat 2. So yeah, some very encouraging results. So the drift in the sea level anomaly was less than 0.1 millimeters per year, which he said was an excellent result, better than the ECV constraint that was set at 0.5 millimeters per year. And then he quantified what he saw as the CryoSat 2 range bias, and again said no apparent drift in that, and no substantial bias in other parameters. So very happy to see the ocean results from that. And then our final talk was from Niels Olsen, which was really interesting on using CryoSat 2 for looking at the magnetic field and looking at changes in the magnetic field. In part, he showed that there was a gap between actual dedicated magnetometer missions from CHAMP and SWARM. So CryoSat 2 helped fill that gap, but it also helped improve the resolution as well by taking data from different satellite. he showed how that really improves the measurements that are being taken. He made a interesting comment that CryoSat 2 magnetic field measurements set a new standard for what's possible for just navigational magnetometers on a mission that's not dedicated to studying the magnetosphere specifically. And again, showed how CryoSat 2 was able to show a specific space-time structure in a geomagnetic storm. So again, thanks to CryoSat 2. The final comment here was really interesting. He made a comment that looking at the magnetic field data, we could look at the oceanic M2 tides from CryoSat 2. And I think Jerome made a question, could we use data like this to de-alias ocean tides in a way? I believe the answer seemed to be yes, but maybe more work needs to be done towards this. So yeah, that's the highlights from our session.
Monica and Nathan, thank you very much for putting together this heterogeneous but very interesting sessions, and sometimes outside your personal field of view, but field of interest. But it was we wanted to do this.
No, it's our field of interest. It's not maybe our field of knowledge, but I'm interested in everything.
You're right.
Yeah,
you're
they
right.
were all very interesting indeed. Yeah, but difficult to make
Okay, let's move to the last but not least session. Jerome, if you can make it in 4 minutes, you get a CryoSat mug one day. So either you or Karina, you have 4 minutes.
Okay, that's a challenge. Okay, so you may, if you can either show our slides, can you? Oh, yeah, okay, I can share now. Okay, so I hope that you can see our slides. So I'm presenting this on behalf of my on Jerome and myself. And in the hydrology session, we had 5 talks, which was a fine mixture of methods and applications. And then we had 4 posters. So there's no doubt that though intended for ice, CryoSat has made really a high impact also for hydrology. And with that, we can mention, which came up in all the talks, that the very dense track sampling in space really have made a tremendous difference. For rivers, it means that we can have targets we have measurements all over the rivers, which enable us to make river profile, which enable us to connect all the data from CryoSat itself, but also other missions. For lakes, it means that we can map significantly more lakes, which we cannot capture with other altimeters. And then Daniel from the Technical University in Munich, he showed that CryoSat have a huge impact in the Tahiti database, where it helps to fill in the gap between the short repeat missions. It's also an important role in making lake volume storage variations. One of the key things about CryoSat is the SAR-in mode, because typically in inland water, we look at very small targets. So with SAR-in, we can actually get measurements where the track is not exactly over the river. So Fillmore showed that an example for the Amazon River, where he achieved 40% more observation in SAR-in mode. So this is really a key point here. There are a lot of methods being developed to derive time series from CryoSat, including also other missions, and many different methods are being made. And this is important because the water level observations feed into discharge and other hydrological modeling. But of course, there's still room for improvement. Now with the 10, 11 years of CryoSat, and the fact that we can measure all these lakes makes this mission an important mission for studying climate change. We had a very nice talk by Li Guangjiang, who showed an example from the Tibetan Plateau, where he looked at a lot of lakes there, and he correlated lake water level change with El Nino, with the El Nino, and he could see that there was a drop that was correlated with the El Nino. Sorry about that. Also, an important thing for inland water is FF-SOM, which will, I think, will play a tremendous role. It's already doing, but also in the future. And we are happy that ESA is making a service so all the users can download this full focus SAR data. And of course, all this improvement will also, we expect more improvement through several projects that is going on. For example, Hydrocoastal, where we have a processing line from all the way from level 0 to level 4 data, which we hope will show even more science with CryoSat 2. And also, of course, the new product that will be available with CryoSimple. Okay, so did I manage my 4 minutes?
You will get a mug one day. No problem on that. So thank you very
know
much indeed.
If, I don't know if Jerome have
it was perfect. Thank you to you and Jerome for putting this together and again helping us. So I think we can go to the Andrew. Do you want to say something before I conclude with a few statements?
No, I don't. I've said far too much already. So thank you to everybody that's put the conference on. Yourself, of course, Tom. So I'll thank you on behalf of everybody else for everything that you do to keep our mission in space.
Thank you to all of you. So a few things just to conclude. Thank you very much, Andrew, for this. And I would like to conclude this conference by taking the opportunity, of course, to thank all the participants, all the speakers for their excellent talks. And I personally thank those who had to attend at impossible times. I would like to convey my gratitude as well to the chairs and to the scientific committee that had to go through the pain of reviewing, I will say, the paper twice for one conference. So thank you also on behalf of everyone. We were privileged this time to have Chris Rapley proposing this session of Future Altimetry, and it was well organized and well directed with the support of Mark. And we are looking forward to the output and the discussion, and believe this conference will also be remembered for this outcome. Chris, it goes without saying that we count on your support for the extension of the mission until 2025 and hopefully beyond. I would like to thank my colleagues Jerome and Alessandro, who have taken the lead of making sure that the program and everything was fine. Everything was fine. And also to Andrada, who has been very active in posting the tweets. Which brings me to the fact, please don't forget to redeem your code to plant the trees, because this is our little but important contribution to uplift the CO2 produced by this virtual event. And last but not least, I think we have to thank Veronica and Matteo for having organized all this and have been working during the conference behind the scenes and